State of matter. Chapter number 5. This is past year NEET trend. So, NEET investigation report. In this target exam is NEET. Predicted question from this chapter is 1 to 3, 1 to 2, and critical concepts are Maxwell distribution velocity and critical phenomena and liquefaction of gases. Critical phenomena and liquefaction of gases. Practice plan. Here chapter starts. Introduction. Introduction is matter exists in three different states known as solid, liquid and gases. There are also two opposite tendency between particle of matter and determine the state of matter. Particle of matter which determine the state of matter, that is intermolecular attractive force and molecular motion, that is random motion. Matters are divided into three types: solid, liquid and gases. Their properties are attractive force, thermal motion, volume and geometry. So attractive force is large सॉलिड्स में, और लिक्विड में स्मॉलर, और गैसेस में ऑलमोस्ट ज़ीरो, और सॉलिड में ऑलमोस्ट ज़ीरो. व्हाट? थर्मल मोशन. हाँ, मोशन नहीं होता सॉलिड्स में. और लिक्विड्स में ग्रेटर होता है लिक्विड्स में. और गैसेस में रैंडम मोशन होता है. और वॉल्यूम की बात करें तो फिक्स्ड वॉल्यूम होता है, इसमें भी फिक्स्ड वॉल्यूम, बट गैसेस में वेरियस कंटेनर होता है. वेरीज विथ कंटेनर के हिसाब से साइज़ होता है, वॉल्यूम होता है. फिर ज्योमेट्री के बेसिस पे डिफिनाइट होती है मैटर की. फिर नॉन मैटर में और एक आता है नॉट डिफाइंड, हाँ, लिक्विड का, गैसेस का नॉट डिफाइंड. Intermolecular forces usually called van der Waals forces. Intermolecular forces generate as the result of neutral attraction of unlike charges or repulsion of like charges. Intermolecular forces generate as the result of neutral attraction. जो न्यूट्रल अट्रैक्शन होता है उससे होता है. इसमें कोई भी इलेक्ट्रॉन्स का उसका चार्जेस का नहीं होता. अनलाइक चार्जेस आर और रिपल्शन ऑफ लाइक चार्जेस. यस. Attraction force does not include the forces between the opposite charged ions and the force that hold atoms of a molecule together, that is covalent. Next, intermolecular forces are of several types. First, dipole, ion dipole, London or dispersion forces. Thereafter, dipole, induced dipole. Thereafter, hydrogen or special type of dipole forces. Ion dipole interaction, in that it is attractive between the ions and dipoles of neutral molecules. Yes, ion and dipole. Examples: it is in water interaction between Na plus and H2O, dipole molecules, or chlorine and H2O. Yes, ion dipole interaction. Next, magnitude of the interaction energy. Magnitude of the interaction energy between depend on the charge on the ion Z, its dipole moment mu, and on the inverse square of the distance r between the ion and the dipole. E is equals to Z dot mu by r square. Ion dipole forces mainly important in aqueous solution में of ionic substances. Example: NaCl in water. Dipole forces: neutral but polar. Neutral but polar experience dipole-dipole forces. These forces are due to electrical interaction among the poles or on neighboring molecules. Interaction. The strength of the dipole moment, the strength of the dipole given dipole-dipole interaction depends on the sizes of the dipole moment involved. As the molecules is molar pole, if the as the molecule is more polar, dipole-dipole interaction are more, and boiling point of substance will be more. Strong dipole-dipole interaction operate between hydrogen and more electronegative fluorine or oxygen or nitrogen is called hydrogen bond. Dipole-dipole interaction in solid is proportional to 1 by r square. Dipole-dipole interaction between rotation molecule is proportional to 1 by r to the power 6. Here r is the distance between polar molecule. More charge density toward iode chlorine and dipole forces. London or displacement forces. Here. Instantaneous dipole on one atom can affect the electrons distribution in neighboring atoms, induce temporary dipoles in those neighbors. As the result, weak electric forces are developed known as London forces or dispersion forces. London forces energies are in the range of 1 to 10 kilojoule per mole. London or dispersive forces. Okay. Symmetrical distribution of electric charges cloud and atom is with instantaneous dipole more electron density on the right hand side, atom B with induced dipole. Okay. Atom A more electronegative density on the left hand side, atom B more induced dipole. And dispersion forces. The magnitude of London forces depend on polarizability and geometry. A smaller molecule or atom is less polarizable and has smaller dispersion forces. Next, a larger molecule or heavier atom is more polarizable and has larger dispersion forces. F2 has smaller dispersion forces, hence it is a gas, whereas I2 has larger dispersion forces and it is a solid. More spread out shape will have higher dispersion forces than those compact molecules that minimize molecular contact, thus have lower dispersion forces. Example, N-pentane, boiling point 22 methyl propane, boiling point is 282.7 Kelvin, compact chain. London forces increase with size, molecular weight, surface area and number of electrons. Dipole induced forces. These forces are in between polar molecule and neutral molecule. Permanent dipole of polar molecule induces dipole on the electrically neutral molecule by deforming into electric cloud and attracting forces develops. Non-polar molecule dipole induced forces. The magnitude of induced dipole moment also depend on magnitude of dipole moment of permanent dipole and polarizability of neutral dipole moment. Ion induced dipole forces. These are the interaction between non-polar molecule polarized by an ion nearer to it. The strength of these forces depend on charge of the ion and the ease with which non-polar molecule gets polarized. That is I2 and NO2 NO3 minus ionized ion induced dipole forces. Hydrogen bond. It arises in molecule in which highly polar NH or OH or SHF bond are present. Hydrogen bonds are formed by highly electronegative elements like NO and F. Strength of hydrogen bond is determined by Coulombic interaction between lone pair of the electron of electronegative atom of one molecule and hydrogen atom of other molecule. For example, hydrogen bond. Thus, hydrogen bond in a special case of dipole interaction, hydrogen bond.